is Miko Fernando, here to talk some of our research about smart biodegradability package. Before we get started, let me introduce you the other researchers who are responsible to our study. My groupmate Alfian Hanafi and Dia Respati Maharani, and also our supervisor Mr. Joko Nugroho Wayukaryadi and Ms. Siti Mariam. Our research title is about smart biodegradability food package innovation based on sugar palm starch waste. Our presentation consists of background, aim, methodology, result, discussion, and conclusion.
Now, we will tell the background and aim of our study. First of all, there are two types of waste that we know are found in the environment. The two types of waste are organic and non-organic waste. Organic waste is example, the leftovers, green waste, dry leaves, and other waste that can be used for composting, while the example of non-organic waste are iron, textile, styrofoam, and any other waste that cannot be used for composting. Nowadays, we know that the daily need for EPS, expanded polystyrene or styrofoam, as a type of food package is commonly used in the food industry. Although this type of plastic material has properties that are quite strong and resistant to support the stability and quality of packaged food, but its inability to degrade in nature is a source of environmental problems that have a serious impact and can disrupt the balance of the ecosystem. Based on the search of Indonesia Ministry of Forestry and Environment, in 2020, Indonesia has produced at least 67.8 million waste, and there are at least 14% styrofoam food package waste out of 30% non-organic waste. Those high amount can cause any harm to the environment and the living creatures. So, what's the solution? We need to use biodegradable products to help the protection of the environment for the better future. Meanwhile, the waste of palm starch is also commonly found in Indonesia. The lack of understanding in the management of the waste of sugar palm starch is a challenge for the sugar palm industry activists, so that the waste can cause any harm to the environment. Based on the data from Akuba 2004 research, Indonesia has approximately 60,482 hectares of sugar palm plantations, and this amount, the waste of sugar palm starch produced, can be utilized optimally. In fact, the waste of sugar palm starch has a fairly high cellulose content of 82.03%, and the cellulose contained in the waste of sugar palm starch can be used to strengthen the physical and the mechanical characteristics in the manufacture of eco-friendly food package. So that based from the background, the aim of our research is to maximizing the utilization of the waste of sugar palm starch in the manufacture of eco-friendly food package to support SDGs 12 as an effort to reduce styrofoam or expanded polystyrene EPS plastic waste.
Then, let's get into the methodology of this study. The material we use are glycerin as a pesticide during the forming of the biofoam, starch solution, we use cassava starch that will interact with sugar palm starch waste, form a dense network structure, PVA or polyphenol alcohol used as an adhesive in the mixture, chitosan as antibacterial agent, then garlic powder containing addition that can be used for anti-insect and antifungal. After all material have prepared, mix it all together in mixture for 10 minutes. After that, pour the final mixture to aluminum mold or metal mold. Bake the mold in oven with temperature up to 150 degrees Celsius for 2 hours. After baking process, take it out and place it in room temperature for 7 days. Based on chain research, we do some characterization testing such as water absorption, mechanical properties, thermal properties, and biodegradability tests.
Let's move to the result. These are the picture of our product that we have made. Has specifications 4.25 inch by 4.25 inch by 2 inch square and 0.2 till 0.3 millimeter thickness. Also with characteristic 100% natural waste material, water and grease resistant, sustainable, biodegradable, anti-insect and bacterial, also non-carcinogenic. So where are these specifications and characteristics comes up? Let's see to the next slides. Food industry want the product that can maintain food quality, safe, and have main interest. Different adhesives was applied to improve biodegradability food package. This table provides an overview of different studies on how material will affect food package, as my team had mentioned before on methodology. Every material has an effect in the process, such as PVA can improving melt strength processability and cellular uniformity. Glycerol can improving cell structure and properties of the foam, and also the other materials has their own effect. From that we get the point. As we know, there is a lot of research about biodegradable foam was made by cornstarch, rice straw, and also bagasse, but none with sugar palm starch, just a little bit information. So we found sugar palm starch waste have similar lignocellulose concentrate with other natural fiber. Because of that, sugar palm starch waste has high potential to become an alternative material. The next is cassava starch that we're using in starch solutions have high amylopectin, so can improve thermal properties, where thermal stability were affected by amylopectin content, where more higher amylopectin content, then it will have a good thermal stability. From the data that we got, cassava starch containing 17% amylose. Relation between amylose and amylopectin is lower amylose content will have higher amylopectin content, and that's why cassava starch can improve thermal properties. Chitosan as an antibacterial agent. From figure number 2, chitosan kill bacteria thrive on interfacial contactin inhibitory effect that occurs on the surface of the microsphere. And from the table 3, chitosan can increase density also thermal properties for bioplastic and other biodegradable products, so it's potentially applied to biofoam. Chitosan also can improve mechanical properties and water resistance. From the table, chitosan concentrations with 6% has a higher water absorption index and water solubility index rather than a lower concentrations. Another information is PVA can improve physical properties with glycerin. Interaction between PVA and glycerin will affect physical properties of foam during the process. So the conclusion that we get is waste of palm sugar starch can be utilized optimally and has high a potential to become an alternative material in the manufacture of food package. Also can be provided that other starch waste have potential use in biodegradable foam. This will make a major contributions of effort to reduce food packaging waste, such as styrofoam in order to support the achievement of SDGs 12 to maintain the balance of the ecosystem towards a better future. So this is a reference that we're using in our research. That's all from us. Thank you for your attention. Don't forget to always caring our future. Thank you.